Okay, so question A shows you some trials that 3 different people have done to try and find the probability of a pin landing either point up or point down. Now the first question says whose results will give the best estimate. If you want the best estimate from a set of trials, you want the short answer to this is it's the person who's done it the most number of times, the person with the greatest number of trials. The reason for that is if you just, at the top of the page, if you think about like flipping a coin, if you flipped a coin 10 times and you got 3 heads and 7 tails, you wouldn't necessarily think of that as like a freak outcome because you've only done it 10 times. Whereas if you flipped a coin 1,000 times and you got 300 heads and 700 tails, that would be a little bit, you might start to think the coin might be biased. It no longer seems like, it's starting to seem like there actually is a problem with the coin in this situation. And that's because the greater the number of times you do something, the more you would expect the probability to sort of tend towards a 50-50 split. So whereas this is understandable when you only do it 10 times, that might happen. This, you'd expect it to be much closer to like 500-500. Maybe not exact, it might be 491 and 509, but you'd expect it to be closer. So the greater number of times you do something, the more accurate your probability will be. And with Mel having tried it 80 times, Lucy's tried it 45 times and Tom's only done it 25 times. So Mel, having done it the greater number of times, she is the one whose result will give the best estimate for the probability. Your reason is just that she's tried it the most times. Okay. Alright. Stuart is going to drop the drawing pin twice. Use all the results in the table. Use all the results in the table. Some of you didn't do this. To work out an estimate for the probability that the drawing pin will land point up the first time and point down the second time. Okay. Well, if we add up these numbers along the bottom up here, there are 150 drops of the pin in total. And out of those, if we add up across the top line, we get 100 that land point down and 50 that land point up. So down here, the probability of it landing point down is 100 out of 150. Let's simplify that. And the probability of it landing point up is 50 out of 150. Let's simplify that. Now you're going to do this twice, so we're going to do a first drop and then we're going to do a second drop. You can use a tree diagram for this. So let's use D for it being point down and U for it being point up. And then on the second drop, we'll do the same thing. So read the question again. Work out an estimate for the probability that the drawing pin will land point up the first time. So we're coming up this way. So point up is a third. And point down the second time. So on the second drop we want it to be point down, which comes up this way. So this is the route we're taking on the tree diagram. If you want the end probability on a tree diagram, you multiply together the probabilities along that path. Because you need it to be point up on the first drop and you need it to be point down on the second drop. If I times those together, that comes out as 2 over 9. And I've got my final answer. Okay, question 10. You have a probability table. Work out the probability of getting a red counter. Well, the probabilities you have so far add up to 0.95. So, what is going to make this add up to 1? Because the probabilities, it says in the question there are only blue, yellow, green and red. So it has to be one of these, so they have to add up to 1. So if I do 1 minus what's already there, that gives me the probability of a red counter. Now, What is the least possible number of counters in the bag? Well, 0.05, if you turn that into a fraction, it's the same as 1/20th. So the probability of choosing a red counter is 1 out of 20. Now if you think about it, I could do equivalent fractions to that. It could be 2 out of 40, I could think of it as 3 out of 60, etc. I can find lots of different equivalent fractions. That means, looking back, if there's 60 counters in the bag, 3 of them would be red. If there's 40 counters in the bag, 2 of them would be red. But the least possible number there can be, if it's 1 out of 20, there must be at least 20 counters in total. Because when you do probabilities, the number on the bottom tells you the total number of counters. You can't go further back than that. Don't start trying to do 0.5 over 10. Because the point is you need the number of red counters to be a whole number. You don't have like a fraction of a counter in there. So the least possible number of red counters in the bag is, wait, hold on, I've confused myself here. If it's 1 out of 20 for the probability of red counters, there must be in total at least 20 counters. So 20 is your answer. And in that situation, 1 of them would be red. Whereas if you go up to the next one, if there were 2 red counters, you'd have 40 in total. So the least possible number of counters in the bag is 20.